Give time.
What? We're here in Wisconsin, America's Dairyland. Smell that dairy air. So of course, we're going to talk about milk. The white stuff that comes out of the mammal's mammary glands. We're at Hinchley's Dairy Farm.
Start from the top, and you're you're getting the last bit of toothpaste out of the toothpaste tube. You got it!
Success.
It's a lot of.
Guess what she makes?
A lot of milk.
You got it!
Oh my god.
No.
Well, it's time to get the fuck out of that place. Let's get back home and do some science. Milk a rat for nutrients.
I'm not.
Shut up, you ain't hard, nigga.
Alright, so we're going to do a milk experiment since we're in the dairy state. This is David, a nuclear engineer / physics engineer at the University of Wisconsin. Those are his qualifications. Mine are this lab coat that I bought from Amazon Prime.
Beat my outfit!
$14.95. So what you'll need for this experiment is some milk. We got the full fat milk straight from Wisconsin, glass bottle. You can't get that in the hood. You also need some food color, some dishwashing detergent, and an applicator. For that dishwashing detergent, we're using a cinnamon stick because we cannot afford Q-tips for some reason. Also a plate, get a plate. You're gonna get your milk, full fat. Pour a thin layer onto your plate. Like so.
Casually drinking milk.
Yeah, get that milk. Full fat milk. Put the lid back on that milk, you don't want any spills. No crying over spilled milk, as they say. Just one dot of each color. Now I'm going to show you what happens when you add that applicator to the milk without adding that dishwashing detergent first. See that? Nothing happened. But when you add the dishwashing detergent, check it out. This is where the magic happens, kids. Oh shit, nigga! So it's kind of like cleaning up the neighborhood. All the whites have moved in, and the colors have been pushed out. Shout out to Detroit. Basically, I don't really know what happened, but that's why David's here. He's gonna kind of give you a scientific explanation of what's going on. There you go.
Not too off base. Much like people, milk is made out of many parts. By and large, the majority element of milk is just mostly water. However, there is a large population, or minority, fat globules. And the fat globules and the water do not mix normally. However, fat globules happen to be surrounded by a protein coating, which acts as an emulsifying agent so that they can exist in a suspended mixture without separating. Now, if you want to separate that mixture, you need to weaken the bonds. That is where the soap comes in. So we apply the soap molecules, which are a polar kind of compound that weakens the bonds. Since they're polar, it means that they have two ends to them. One is hydrophilic, one is hydrophobic. So the hydrophilic portion of the molecule wants to latch on to one of the water molecules. Meanwhile, the other end of it wants to connect or bond to one of the fat globules. Since the fat globules are minority species, they're interspersed throughout the liquid, what you witness is kind of a molecular gymnastics, where you have, once one of the soap molecules bonds onto one of the water molecules, then you witness the molecules themselves bending and contorting, rushing towards the edges very dramatically, just trying to latch onto one of the fat globules that are just scattered throughout the mixture.
And that's what's happening there. Give time.
Give.